Stop what you're doing, right now, because I'm about to ruin the night sky for you forever. You walk outside tonight, you look up, what do you see? Darkness. A few stars scattered here and there, maybe the moon. And your brain says, yeah, makes sense. The sun went down, so it's dark. But here's the problem. Your brain is lying to you. That darkness, it shouldn't exist. According to basic logic, the night sky should be blindingly bright, like staring directly at the surface of the sun. Every single pixel of your vision should be pure fire. You should be roasted alive in seconds. But you're not. And that's the paradox that broke astronomy for centuries. Let me explain with a thought experiment. Imagine you're standing in the middle of an infinite forest, trees everywhere. You look straight ahead, you see a tree trunk. You look to the left, another trunk. You look between the trees, more trees behind them. Now here's the key. If the forest goes on forever, no matter where you look, your line of sight will eventually hit a tree. You might have to look far, but eventually, smack. You hit wood. You can't see the sky. You only see a wall of tree trunks. Now replace the trees with stars. If the universe is infinite and if stars are scattered evenly throughout it, then every single direction you look should eventually land on the surface of a star. Every single direction. That dark patch of sky you see? You're just not looking far enough. If you waited long enough for the light to reach you, or if you had a strong enough telescope, you'd find a star there. So the entire sky should be covered in stars. And since stars are insanely hot and bright, the whole sky should glow like the sun. Not just bright. Blinding. You'd be vaporized instantly, but you're not. So what's going on? Now you might be thinking, wait, stars that are far away are dimmer. They fade with distance. So obviously the sky is dark. That sounds logical. But here's where nature plays a sick joke on you. Yes, individual stars get dimmer with distance. We know this. It's called the inverse square law. If you move a star twice as far away, it looks 1/4 as bright. The light spreads out over a bigger area, so it gets weaker. But here's the trick. While each star gets dimmer, the number of stars increases. Perfectly. Imagine a hollow shell around Earth at a certain distance. Count the stars in that shell. Now imagine a second shell twice as far away. Because it's twice as far, the surface area is 4 times bigger. And if stars are scattered evenly, there are 4 times as many stars in that shell. Do you see what just happened? The stars in the second shell are 4 times dimmer, but there are 4 times as many of them. The total light is exactly the same. Add a third shell, a fourth, a millionth. Each shell contributes the exact same amount of light. If the universe is infinite, you're adding infinite shells, which means infinite light. The math cancels out perfectly. It's like the universe is trolling us, so the dimness argument fails. The geometry won't let you escape. Okay, so we're stuck. One of our assumptions has to be wrong. Let's go through them. Maybe the universe isn't infinite. Maybe there's an edge, a wall where the stars just stop. But that seems ridiculous. Nature doesn't build brick walls in the middle of nowhere. Maybe stars aren't evenly distributed. Maybe they're clumped up in certain areas. But when we look through telescopes on a large scale, the universe looks pretty uniform, pretty smooth. Here's another excuse people use to believe. Maybe there's dust out there, dark clouds blocking the light from distant stars, like cosmic smog. Nope, doesn't work. This is thermodynamics. If you shine infinite light on dust, the dust heats up. Eventually it gets so hot that it glows just as bright as the stars behind it. The dust becomes a light source. You can't hide energy, you can only move it around. So the dust theory is dead. We're out of excuses. We're stuck with a paradox that says we shouldn't exist. And that's when science gets interesting. Because when you find a paradox, when logic contradicts observation, that's where the treasure is buried. That's nature telling you you're missing a huge piece of the puzzle. And the piece we're missing? Time. For thousands of years, people assumed the universe was eternal. It just always existed, ticking away like a perfect clock. Infinite past, infinite future. But this darkness, this simple dark night sky, whispers something terrifying. The universe had a beginning, and that changes everything. If the universe had a birthday, let's say about 13.8 billion years ago, then we're not looking at an infinite forest. We're trapped in a bubble, a time bubble. Light travels fast, about 186,000 miles per second. That's insanely fast. But the universe is bigger, way bigger. When you look at a star, you're not seeing it as it is now. You're seeing it as it was when the light left it. If a star is 4 light years away, you're looking 4 years into the past. You're looking at a ghost. Now, because the universe has a beginning, there's a limit to how far back we can see. There's a horizon. Not a horizon of space, but a horizon of time. Imagine the universe is full of stars, infinite stars going on forever. But they only turned on 13.8 billion years ago. We can only see the stars whose light has had time to reach us. If a star is so far away that its light takes 20 billion years to get here, we can't see it yet. The light is still traveling. It's rushing through the vacuum, trying to reach us, but it hasn't arrived. It's like a letter in the mail that hasn't been delivered. So when you look up, you're not seeing the whole universe. You're seeing a small sphere, the observable universe. The stars close enough for their light to have reached us since the beginning. And because this bubble is finite, the number of stars is finite. There aren't enough to fill the sky with fire. There are gaps, lots of gaps. And through those gaps, we see darkness. The darkness of nothingness before the stars were born. The sky is dark because the universe is young. 13.8 billion years sounds like a long time, but for the purpose of filling the sky with light, it's just a blink. If this is blowing your mind, drop a comment saying the universe is a baby, because it is. But wait, there's more. And this is where it gets even stranger. The universe isn't just young. It's moving. It's expanding. Space itself is stretching. Imagine baking a cake with raisins in it. As the dough rises, the raisins move away from each other, but they're not moving through the dough. The dough between them is expanding. This expansion does something weird to light. Light is a wave. It has crests and troughs. The distance between two crests is the wavelength. For visible light, wavelength determines color. Blue light has short, choppy waves. Red light has long, lazy waves. Now imagine a photon leaving a distant galaxy and heading toward Earth. It's traveling through space. But while it's traveling, space is stretching. What happens to the wave? The wave gets stretched too. It's like drawing a wave on a rubber band and then stretching the rubber band. The wave gets longer. The color shifts toward red. We call this redshift. If the galaxy is very, very far away, the light gets stretched so much that it shifts out of the visible spectrum entirely. It becomes infrared, then microwaves, then radio waves. So the light from the most distant sources, the light that would fill those gaps in the dark sky, is being weakened. Its energy is being diluted by the expansion of space. So we have two things saving us from being cooked. First, the universe hasn't been around forever. Second, space is expanding, stretching the light, sapping its energy, shifting it into invisible colors. So when you look at the empty spaces between the stars, are they really empty? No, they're not. If you had eyes that could see microwaves, the night sky wouldn't be dark at all. It would be glowing. There's a glow that comes from everywhere. It's uniform, constant. It's called the cosmic microwave background radiation. What is it? It's the afterglow of the Big Bang itself. In the beginning, the whole universe was hot, dense, and glowing white hot. It was a fog of plasma. Light couldn't travel freely. Then the universe expanded and cooled. It became transparent. That trapped light was released. That light is still here. It's filling every cubic centimeter of space right now. It's raining down on your head as we speak. But because the universe has expanded by a factor of 1,000, that blinding white light has been stretched into microwave radiation. It's cold fire. If you turn on an old TV and tune it to static, about 1% of that snow is actually the cosmic microwave background. You're watching the Big Bang. You're watching the birth of the universe on your TV screen. So is the sky dark to our eyes? Yes. But to the universe? No. The sky is full of the oldest light in existence. We just don't have the equipment to see it. Here's the beautiful, terrifying truth. We are trapped in a delay. We live in a reconstruction of reality based on outdated information. When you look at a star, you're seeing the past. Some of those stars might not even exist anymore. They burned out millions of years ago. But the light carries the news, and the news travels slow. The darkness of the night sky is the condition for our existence. If the sky were not dark, we wouldn't be here to see it. A simple observation. It's dark at night. And if you follow the logic, it leads you to the Big Bang, to the expansion of space, to the finite speed of light, and to the very structure of time itself. You don't need a billion-dollar particle accelerator to do physics. You just need to look out the window and ask why. So the next time you look up at the night sky, don't see darkness as the absence of light. See it as the echo of the beginning. See it as the cooling of the great fire. See the gaps between the stars not as empty space, but as the deep stretching fabric of a universe that's running away from us. If this made your brain hurt in the best way possible, smash that subscribe button. Because here at the Curiosity Beast, we peel back the layers of reality and expose the uncomfortable truths hiding underneath. Drop a comment telling me which part broke your brain the most. First, the universe hasn't been around forever. Second, news, and the news travels slow. The darkness of the night sky is the condition for our existence. If the sky were not dark, we wouldn't be here to see it. A simple observation. It's dark at night. And if you follow the logic, it leads you to the Big Bang, to the expansion of space, to the finite speed of light, and to the very structure of time itself. You don't need a billion-dollar particle accelerator to do physics. You just need to look out the window and ask why. So the next time you look up at the night sky, don't see darkness as the absence of light. See it as the echo of the beginning. See it as the cooling of the great fire. See the gaps between the stars not as empty space, but as the deep stretching fabric of a universe that's running away from us. If this made your brain hurt in the best way possible, smash that subscribe button. Because here at the Curiosity Beast, we peel back the layers of reality and expose the uncomfortable truths hiding underneath. Drop a comment telling me which part broke your brain the most. And if you looked up at the sky differently after this, you're officially one of us. I'll see you in the next one. Stay curious, Beast.